In this lesson, we're going to talk a little bit about testing our asymptotes. This is a really important thing to do once you've found an asymptote, because the whole goal of finding the asymptotes and all of the other key features of equation is so that we can put it on a graph. And so let's take a really simple rational equation like 1 over x. If we found the vertical asymptote for this function, we can see that if x is equal to 0, we would end up with 1 over 0, which is a value of infinity, which is an undefined value, something that we can't put on the graph, that we can't show on the graph. So we say then that the equation x equals 0, the line x equals 0, which is also the y-axis, is an vertical asymptote for this particular graph. So one of the things that we want to find out about what's happening near this line is how the curve is behaving. So on our xy axis, what we've determined so far is that the y-axis, or the line x equals 0, is our vertical asymptote. And we know that that means that the curve is not going to cross that line. So what we do want to know is, as it gets closer and closer to that line, what does the curve look like? Can we shape the curve, and can we get an idea of the direction of the curve as it gets closer to that line, knowing that we're never going to actually be on that line or cross that line? So what we do is we test the limit as x approaches 0 from the right of the function 1 over x. And what that means is, as we're traveling from the right towards our y-axis, what is the curve doing? What does it look like? So a value just before we get to x equals 0 would be something like x equals 1, right? So if I put 1 over 1 in here, then I get positive 1. And the positive is a really important thing, because we know that when we get to 0, we're going to infinity at that value. So as we're coming towards that asymptote from the right direction, we're in the positive values going up towards infinity. So that tells us that when we get close to that axis, we have the curve going upwards towards infinity as it gets closer and closer to that axis. Now, if I do the same thing, and I take the limit as x approaches 0 from the left of 1 over x, then a value that I would travel through just before I got to the y-axis as I was coming from left to right might be negative 1. So let's put in minus 1, and I would get a value there of minus 1. And the value doesn't matter so much as the sign. If it's negative, it tells you that this particular curve is going down towards infinity as it approaches that x-axis. And so we get a really good idea of what our curve is going to look like as it gets near that asymptote. With the horizontal asymptote, if we're working with the same equation, 1 over x, then our horizontal asymptote is going to be the limit as x approaches infinity of 1 over x, which means if I put a really large value in the denominator, like infinity, what's going to happen to the overall value of the equation of this function? Well, 1 divided by infinity is going to be so small that the limiting value is basically 0. And so that tells us that we have a horizontal asymptote at y equals 0, which is also the x-axis, isn't it? So here's our grid again for the same function, and this time with the horizontal asymptote, we now know that y equals 0, or the x-axis, is an asymptote. With a horizontal asymptote, usually the graph doesn't cross this line. Sometimes, though, the graph will cross a horizontal asymptote, so that is not a 100% rule, or a rule that's written in stone. But most of the time, you can rest assured that if you have an asymptote, the graph will either be below it or above it. So let's find out for this particular graph which one it's going to be. For this, what we do is we test the asymptote for really large values of x and really small values of x. And so a really large value of x would be something like x equals 10. And so we put that in there in the equation 1 over x minus the asymptote, which in this case is 0. But if the asymptote happened to be at y equals 2 or y equals 3 or something like that, you would have 1 over x minus that value. Now, if I put 1 over 10 in there, what I'm concerned with is whether or not it's positive or negative. That's all I care about, not whether the value is big or small. If I do the same thing, as x approaches negative 10, I would get 1 over negative 10, which is going to be a negative value, and again, that's all I care about. Because the positive in the first example tells us that this curve is going to be, above the asymptote. This negative in the second example tells us that the curve will be below the asymptote. So for positive large values of x, we're going to be above the curve, or above the asymptote, For large negative values of x, we're going to stay below the asymptote. And so if you combine that with the information that we got from the vertical asymptote, we already have a really great idea of what this graph is going to look like just by how the curve is behaving as it gets near our vertical and horizontal asymptotes.